Hi everyone, welcome to the Knauss Brown Bag 3-minute thesis. I know everyone's very excited to be here. I'm the host, my name is Sarah Markowitz, and welcome to our listeners on the webinar. Hey. So I'm just gonna give a quick rundown of the rules. They're very simple, but each speaker will have 3 minutes to talk. They only have one slide that they're allowed to use as reference. And then in between, we're gonna have about 1 minute just to set up for the next speaker and the next talk. And then at the end, we're going to have 2 audience voted awards. One is for like the best verbal presentation, which is called Your Words Were Heard. So we're going to have an in-count audience vote, and then online we have a poll. And then we also have an award for the best presentation looking slide called Your Slide Jived. And then some cookies for the winner for incentive. So we're going to start off with Lauren Gibson. She'll be going first. She'll have 3 minutes, and she'll be talking about solenodon survival and her thesis research. Good luck, Lauren. Thanks, Sarah.
All right, are we good with the timer?
Yes, and there will be a yellow light for 1 minute and a red light for 30 seconds.
Nice.
Yeah.
This is like very official here.
Yeah.
All right. 75 million years ago, the Earth was a very different place. It was the time of the dinosaurs, though it would still be a few million years before some fan favorites like T-Rexes entered the scene. But there was already another equally weird and wonderful creature in existence called the solenodon. And unlike the dinosaurs, the solenodon actually still survives today. So the Hispaniolan solenodon, pictured here, roughly resembles a bunny-sized version of the rodents of unusual size from The Princess Bride, and it's equally weird. It produces its own venom, which it uses to paralyze its prey, like tarantulas, scorpions, giant millipedes, and other equally terrifying insects. However, despite their venom and their long history of survivalship for 75 million years, the solenodon is now at the brink of extinction. And although scientists generally blame the usual suspects of climate change, habitat fragmentation, and other issues on their decline, nobody really knows what factors shape its decline and distribution, until recently. Over the past 5 years, I've dedicated myself to figuring out what determines the solenodon, its past survival, what limits where it can live now, and what that really means for the future. So I did this through creating species distribution models. These models link known solenodon areas of occurrence with different environmental data layers, things like human population density, climate, temperature, and create a map of where the species might be able to occur. So my models created some interesting outputs. In the past, as you can see on the left here, before humans really took over the landscape, solenodons were distributed fairly evenly. Climate was the main determinant of their distribution, with wide swatches of suitable habitat shown in the darker gray here, and pretty gentle distribution and transitions between suitable and unsuitable habitat. Contrast that to their modern distribution. Human population density is really now the main driver of solenodon distribution and decline. And we can see some pretty stark differences between areas and strong lines fragmenting their habitats. And this is because humans generally take dogs with them wherever they move. So anywhere that humans are, and dogs are significantly better at hunting than solenodons are at running away. But because humans are the reason for solenodon endangerment, we can also be the solution. I'm currently working to spread this science to conservation policies locally, and also working to inform local conservation and children through writing a solenodon children's book. So while the solenodon's in trouble, there's still hope for it, hopefully surviving for 75 million more years to come.
Thank you, Lauren. What a wonderful presentation. That was awesome. Great way to start off the afternoon. So next we have James Murphy, who will be talking to us about coral stress. Good luck.
Aloha Avakea, good afternoon. Aloha Kakahiaka to those that are listening out on the West Coast and further west. My name is James Murphy. I'm a Hawaii Sea Grant Fellow, Knauss Fellow with Office of Ocean Exploration and Research here in NOAA. And part of my dissertation was examining antioxidant enzyme activity and natural cycles of them in Postlopera damicornis, the reef-building coral. If you've been following news about coral reef health over the past couple years, couple decades in some places, you've probably heard about a lot of higher incidences of coral mortality occurring. A lot of that due to either anthropogenic sources of stress or, and climate change influences. And our lab recognizes that really mortality is not a good indicator of coral health or corals getting to a state where they're starting to get too stressed out. So we've been trying to adapt and adopt biomarkers for pre-mortem stress evaluations. And antioxidant enzymes are actually great biomarkers for this because they respond to or are upregulated activity levels pick up during levels of stress under a broad amount of different types of stressors. However, we've also recognized in our laboratory that there is a need to not only use these immediately for stress evaluations in corals, but also understand what are baseline levels. What do they look like in corals? Do these shift over different temporal periods in response to different natural events? And based on previous research coming from our lab, we found that xenobiotic resistance proteins, such as cytochrome P450, are found to upregulate in activity during parts of a lunar phase, a lunar cycle. So in these two, it was during a full moon and then during a 1/4 and new moon, 3/4 and new moon in, again, Postlopera damicornis. With my experiment, I designed the experiment to include sampling around a 1/4 moon cycle with Postlopera damicornis over in Kaneohe Bay, Oahu, Hawaii, and found that superoxide dismutase and glutathione peroxidase were expressing significantly higher activity during 3/4 moon cycles in this coral, while 1/4 moon cycles we saw a peak in catalase and glutathione peroxidase. And so this is really important because this will aid in instructing our sampling regime for the future to make sure that we don't sample during these peak times, or at least keep these peaks, these baseline levels of enzyme activity spikes in mind when we sample to reduce confounding factors. And also this helps to influence the greater management community by better understanding how these corals cycle in baseline levels during lunar cycles, and potentially expand these types of analyses to other types of enzymes, increasing our molecular biomarker toolkit. I think I'm done a little early, but if you have any other questions, I'd be happy to answer afterwards.
Really great job, James. Thank you so much. Everyone's always interested in corals. So next we have Katie O'Reilly talking about the Great Lakes.
Awesome. Thank you, Sarah, for organizing this. Thanks, everyone, for coming out. I actually want to give you guys a challenge. Take a moment to close your eyes and think of a beach. First thing that comes to your mind. What does it look like? I can tell you, for me, the beach that comes to my mind has rolling waves of pea soup green water and is covered with mussel shells sharp enough to cut open your feet. As a kid who grew up on the western shore of Lake Erie, this was my first impression of a beach. With nearly 40 million people living and relying on the Great Lakes as a source of drinking water, recreation, and transportation, it's probably not surprising that this is a place where conflicts often arise between humans and their environment. That beach experience I told you about was the result of some of those conflicts. The pea soup green water was a result of algae blooms from runoff from the surrounding agricultural land. The shells that cut open my feet were actually from a stowaway, an invasive species that had come over on the big cargo ships from Europe and Asia. The Great Lakes really provide this ideal place to study, for ecologists like me, to study how humans are dramatically changing the environment around them. More often than not, these issues intersect and kind of come to a head in where the land meets the lake, basically coastal areas such as coastal wetlands. Now, to give you some background, coastal wetlands in the Great Lakes are kind of the understated ecological MVP. They provide really critical habitat for a variety of plant and animal species, including economically important fish. And they also help improve water quality by acting like sponges to soak up some of the runoff from the surrounding land. But despite their importance, nearly half of all wetland area has been lost since European settlement of the basin, and the wetlands that we do have left are threatened by a variety of factors. My ongoing dissertation research is kind of better understanding the function of these ecological MVPs, these wetlands, and how those functions may change over time due to human impact. Particularly, I'm interested in how fish use the coastal wetlands throughout their lives. That is, trying to answer the question, when are they using the wetlands, which wetlands are they using, and why? But because fish are notoriously difficult to interview, we have to do we use a couple different techniques. The one I'm particularly focusing on is a technique called otolith microchemistry. So otoliths are fish ear bones that kind of form, think of it like tree rings. They form these annuli. And they also incorporate the chemistry around them, and we can use that chemistry to reconstruct their life history. So while the Great Lakes face great challenges, we will need innovative and great solutions to fix them. Thank you.
Great job, Katie. Excellent. So next we have Sami Dowdell, who's going to be talking about water quality dependent industries in Florida.
Okay. So good afternoon, everyone, and thanks to the Knauss Brown Bag Committee for organizing this event. My name's Sammy, and I'm going to be presenting the research that I conducted at the University of Miami. So Biscayne Bay, Florida was identified as a NOAA habitat focus area in part because of the region's dependence on a healthy ecosystem for fisheries, recreation, tourism, and other economic activities. However, water quality in Biscayne Bay is degraded by numerous sources throughout Miami-Dade County, including coastal development and freshwater inflows from canals. The purpose of my study was to characterize sectors dependent on water quality, specifically commercial, recreational, and for-hire fisheries, as well as seafood wholesalers that source from the bay and recreational businesses that depend upon a healthy bay, like scuba and snorkel operators. So as you can see, the specific objectives of this research were to construct socioeconomic and resource use profiles of the focus sectors, to describe current water quality conditions as perceived by stakeholders, and to describe stakeholder adaptation strategies in the face of changing water quality. So my team and I used online surveys and in-person interviews to reach our stakeholders. And on the right, you can see three examples of the outputs for recreational fisheries, as well as a table describing the influences of tenure and industry on perceptions of water quality. The top left figure demonstrates where recreational fishers reported fishing in and immediately outside of Biscayne Bay, and we determined that fishing effort was concentrated in the southern half of Biscayne National Park. To take things a step further, we asked fishers to identify specific fishing grounds within each fishing region, producing the map on the top right. And this map tells us that fishers prefer to fish farther offshore, and in many cases, even farther offshore than this map demonstrates. So respondents were also asked to identify the specific areas of greatest water quality concern, presenting the map on the bottom left. And you can see that identified areas of water quality degradation were more concentrated, especially in nearshore areas, than the fishing areas were. And finally, I was interested in determining if stakeholder sector and/or tenure could be used to describe differences in perceptions of water quality. So tenure here refers to the length of time a stakeholder has been working in their sector. And the top row in the table indicates that all stakeholder groups perceived water quality to be declining, and that tenure may have had some influence over the extent to which stakeholders believed water quality to be declining. Stakeholders were also asked about the types of degradation they observed and about the potential causes of water quality degradation, and views on the types of changes and the causes of degradation varied by sector, but not by tenure. Finally, respondents were asked how they would adapt if water quality in their preferred areas declined to a point where they could no longer operate. And adaptation strategies, again, varied by sector, but not by tenure. So this study presents a wide range of socioeconomic, resource use, and perception-based data for Biscayne Bay water quality dependent industries, and it can be used in future analyses to determine any major demographic, economic, and resource use shifts. All right, that's it.
Really excellent job, Sammy. So next we have Grace Ferrara, and she's going to be talking to us about her thesis work on vulnerability assessment.
All right, so although climate change is a global threat, it is advancing most rapidly in the Arctic. In some areas of the Arctic, the ice-free summer period is a month longer today than it was 30 years ago. Climate change threatens the ecosystem with widespread trophic shifts that may result in the extirpation of many species from this region. Resource managers are tasked with responding to these threats using the best available science, but when that science is limited by harsh Arctic conditions and the cryptic nature of Arctic species, finding the best management solutions is difficult. This challenge can be met using a climate change vulnerability assessment. For my master's thesis, I applied this framework to assess the vulnerability of 8 species of marine mammals in the Bering Sea that are harvested by Alaska natives for subsistence. But what I want to focus on today is the method itself and how it can be widely adopted by resource managers to address climate change. So this climate change vulnerability assessment framework was developed by the IPCC. It combines exposure to climate change, or the stressors imposed on species by climate change, with sensitivity, which is characterized as the response of the species to change, to determine the potential impact of climate change. This is then mitigated by the species' adaptive capacity, or their ability to withstand environmental change. So these components can each be quantified by breaking them down into indicators. For example, exposure indicators in the Arctic include dependence on sea ice and snowpack. A scoring criteria can then be developed based on the resolution of the data. The more data and less uncertainty that exist, the more complex the scoring system can be. Then the scores for each indicator can be added together, either quantitatively or qualitatively, to get the final scores for each component. So because of the extremely limited data for the species that I assessed, I used a semi-quantitative approach wherein I scored the indicators on a 3-point scale and then combined those scores qualitatively. I felt that this approach best incorporated the uncertainty of the data. So then you just have to follow the framework to get your vulnerability scores. The key step for managers, however, comes next. By breaking these components down into individual indicators that are scored in isolation, weak points that could benefit from adaptation solutions are exposed. So this is where managers can target their resources to reduce the impacts of change on particularly vulnerable species. This process is meant to be iterative as conditions change and more data become available. So for anyone who is curious, these are the results for the species that I applied the framework to, from high vulnerability in red to low in yellow and data deficient in gray. In continuing this research, I hope to use the results of this assessment as the exposure component for a community vulnerability assessment. And to learn more, you can join me at my Knauss Brown Bag next week. Thank you.
Wonderful, Grace. Thank you for sharing that with us. And she'll have a brown bag next week. How exciting. So next we have Noel Olson that's going to be talking to us about Jonah crab.
All right. Just curious, how many of you people have heard about Jonah crabs aside from meeting me? Okay, not that many. The 2 main questions people ask me when I say I study Jonah crabs are where do they live and do people eat them? So Jonah crabs can be found all along the eastern coast from Newfoundland down to the Caribbean, but people in New England are really the only area where I've seen people eating them. They can grow up to 5 to 6 inches wide and looks like a smaller version of a Dungeness crab, but they have large claws like seen in Florida stone crabs. Historically, they've been considered just a bycatch of the American lobster fishery, and the crash of the southern New England lobster stock has really catalyzed a targeted Jonah crab fishery. In June of 2016, the Atlantic States Marine Fisheries Commission started a fishery management plan for Jonah crabs, but until very recently, there has been very little research done on their biology. In the past 25 years, both the landings, which is the orange bars on the graph, and the ex-vessel value, which is the yellow line, have increased 5-fold. So for my master's research, I estimated the size at sexual maturity of Jonah crabs in the mid-Atlantic bight. Size at sexual maturity is a useful metric for management and typically applied to setting minimum legal sizes. Essentially, you want to have your species of interest get a chance to mate before you remove them from the population. And my results actually suggested that both male and female Jonah crabs in the mid-Atlantic reach sexual maturity well below the minimum legal size, which makes it have a potential of becoming a very sustainable fishery. I do believe a formal stock assessment should be completed to better understand Jonah crab population dynamics before the fishery continues to grow, which I expect will happen. And if Jonah crabs can be considered a sustainable resource, there should be research on marketing to promote this resource outside of New England. Jonah crabs could relieve pressure on other crustacean fisheries, like the Florida stone crab claw fishery, and it could also provide an alternate source of crab meat, which could help decrease dependency on imported species, which might not be managed sustainably. Also, the Jonah crab fishery could help sustain jobs for fishermen, like the lobstermen in the southern New England area. And I have eaten many Jonah crabs throughout my time in grad school, and I definitely recommend that you try them if you ever see them on the menu.
Wonderful. Thank you so much, Noelle. Next, we have Bridget Kotti, and she'll be talking to us about some land use.
Hi, good afternoon. And Katie, I'm going to admit, when I picture the coast, I definitely see something a little more idyllic, like the white sand beaches of Pensacola, Florida. But I'm sure our interactions, many of the people in this room, with natural places like the coast, really shape the reason why we're here at NOAA or our Knauss Fellows currently. And we're not alone in our love of the coast, right? There are roughly 40% of the U.S. population lives in the coastal counties that border either the Great Lakes or the ocean. And this makes them really strong economic drivers that actually contribute roughly $8 trillion to America's GDP. But as these images of Myrtle Beach, South Carolina show, we can see that that migration to the coast really results in changes to our land usage. So we see the transformation from green, soft, natural spaces to hardened gray infrastructure over time. And that change comes with a real cost. So research demonstrates that the negative impacts to living marine resources begin to occur once hardened surfaces cover about 20% of the neighboring land area. So how do we balance the needed environmental protection with the desire of so many people to live at the coast and the development that accompanies that? Well, fortunately, Congress recognized that the challenges facing our coasts was a national priority. So in 1972, they enacted the Coastal Zone Management Act, which established a voluntary relationship between our coastal states and territories and our federal government. Today, there are 34 coastal programs working throughout the country to ensure that the best available science and policy tools are used to protect, restore, and enhance America's coastal places, while also allowing for the sustainable economic viability of those local communities. The nonprofit Coastal States Organization, or CSO, helps to increase the national capacity of these state programs. They provide a national platform for peer-to-peer learning, and they also partner with other nonprofits and federal agencies to make sure that they share resources with coastal programs tackling the impacts of land use change and climate change, including declining water quality, beach erosion, and the spread of invasive species. This initiative of partnering with federal agencies led to my position, which was with the Environmental Protection Agency and CSO. And EPA brings to the table helping states address water quality impacts, especially through comprehensive watershed management techniques. Though this fellowship is new, we've demonstrated some success, and we've connected resources with Maryland and Washington coastal programs in helping local communities address the impacts of climate change on their water resources. So CSO and EPA both believe that going into the future, working together to provide resources for programs on the ground is the best way to ensure that that beautiful idyllic image is sustained long into the future. Thank you.
Thank you, Bridget, for that very informative talk. Next, we have Emily Markowitz, and she'll be talking to us about some northeast groundfish. Thank you, Sarah. So it's a wonderful day in summer, everyone, right? So nice that you chose to spend it indoors in the AC. Well, as you might imagine, fish do not have air conditioning in the ocean, and they sometimes have to pull a Grandma Lillian and find a new place to live that have favorable conditions. So I studied summer flounder and black sea bass, two commercially important migratory groundfish on the northeast coastline of the United States. And these fish live in shallow, brackish estuaries in the summer, and then overwinter offshore past the shelf in relatively warmer water in the winter. So in the Northeast, we're very lucky to have a fisheries independent survey that's done throughout the area. And so that counts fish using a randomized stratified survey design. The survey works like a snapshot in time, taking surveys in the spring and the fall since about the 1960s. Interestingly, the survey has captured more of these fish in recent years, and though the ship's effort throughout the area hasn't changed, it could mean that the availability of the fish to the survey has changed in possibly one of two ways. One is that either there are more fish in the survey, the population has actually increased, or since these fish are migratory and not resident in the area, the timing of the fish entering the survey area as the survey is happening has possibly changed, and that might be related to climate change. Not only that, but I figured that there would be differences between young fish and old fish, and as well as different seasons. Smaller fish need different things, smaller organisms need different things than adult organisms do, and winter is for mittens and summer is for beach balls and sandals. So there are a few ways of finding out why summer flounder and black sea bass may snowboard to new locations. I used two different analyses to find and define what favorable habitats were for these fish. First, I used a cumulative distribution function to find the preferences of these fish, and then I used a generalized additive model to try and quantify what was suitable habitat along the coast. And I input variables like temperature and salinity, depth, bottom type, and ocean productivity being food. Both analyses came back with some very similar conclusions. Both species experienced significant distributional shifts in their northeast distributional shifts, and that for the summer flounder, temperature and depth was really important, and for black sea bass, temperature was really important. Since these distributions are shown to be shifting, it could mean that we should consider having some adjustment to the availability in these surveys to better understand how many fish are actually there. Thank you. Thank you, Emily. Really great job. Okay, so our next speaker is Sarah Margolis. I didn't have anyone to introduce me. And I will be talking about, I didn't start yet, I'm just gonna introduce, okay. I will be talking about optical technologies and data storage and making them accessible to machine learning. So I'll start now. So optical technologies are incredibly important. They're super cool. They allow us non-aquatic creatures to peer into the marine environment, into the world that lives below us. And us, as scientists and conservationists, we think it's really important and we value the life and the biodiversity that lives in the ocean. But what lives in the ocean are also very incredibly important resources for the United States. And they add job security and food, and they add into the economy, and they're really important to look at. So NOAA Fisheries uses optical technologies to collect information about these resources in the ocean. We conduct fish surveys, and we do habitat assessments. And when we collect this data, we have a ton of information. We have millions of files, we have thousands of hours of video, and where does all this information go? And where can we find it? And who in the world has the time to look through all of it? So let me answer those questions. Currently, video and images collected by NOAA Fisheries is mostly stored actually locally at the scientists' desks on hard drives or at the individual fisheries science centers. This presents an issue because all of NOAA's data must be available to the public as per PAR, which is public access to research results. So there needs to be an effort to centralize this storage and make it accessible, mostly by a user portal or something that users can access online easily. So a key to storing and finding this data is standardized metadata. Metadata is basically information about the data, whether it's the cruise ID, location, or actually annotations of what you're actually seeing in the video. So also, who has the time to look at all of this data? The answer is nobody has the time, but we do it. We spend time and we spend money and we look through all the data and we annotate it to try to find information for our stock assessments. But luckily, machine learning has entered the world of environmental processing. Machine learning are basically computer algorithms that don't have to be explicitly programmed by people and can train on their own. So NOAA Fisheries has made efforts towards creating a computer programming software that will go through and analyze this video, and in the future, hopefully we'll be able to identify fish, species, length, counts, and all the information that we use for our critical stock assessments. So this year, VIAME, which is the Video Image Analytics in the Marine Environment, is rolling out, and our scientists at the Fisheries Science Centers will be trained how to use this program. So in order to use the machine learning to decrease efforts in time and human processing, the video needs to be stored and made accessible for other scientists and also our third-party users such as machine learning software. So thank you very much. Okay, great job, Sarah. Great job. Really informative information. Okay, so as you may have noticed, we had two people that actually weren't here today, so we just had a few of the fellows. And so now we are actually going to do some voting. There's a lot of people here, and I was just going to hand count. I don't know, do we still think that's the best way to go about it? Okay, so we finished a bit early, so we have some time. And for the viewers at home, we have a webinar poll. But to remind everyone, we have 2 audience-voted awards. We have one for Best Oral Presentation, which is called Your Words Were Heard. And we have one for Best Slide, which is called Your Slide Jived. And maybe I might just scroll through one last time the slides so you have everyone's in mind, if that is helpful as a reminder. And then I'm not going to ask everyone to re-give their presentation, so hopefully you remembered how those presentations went. All right, so keep this in mind. And so the first one was Lauren Gibson. This was James Murphy. Am I going at an okay pace? Okay. Katie O'Neill. I'm sorry, O'Reilly. Sami Dow. Grace Ferrara, Noel Olson, Bridget Kotti, Emily Markowitz, and Sarah Markowitz. Okay, so we're not going to be shy. We're just going to do this in front of everyone. So the first one, I guess, because you just saw the slides, we'll do best slides. So online, the voting will start, and so hands up for Lauren Gibson. And everyone did a really great job, by the way. So just so everyone knows and no feelings are hurt, but Lauren Gibson. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. All right. All right, James Murphy on corals.
Wait, is this for words or no?
We're doing the slides first, visuals first. All right, James Murphy. 1, 2. We loved your presentation. All right, Katie O'Reilly. 1, 2, 3, 4, 5. Okay. Did I catch you? 6. Okay. All right, Sammy. 1, 2, 3. Great. Grace Ferrara. 1, 2. Oh my gosh. All right, should I start at the next one or should I? I'm sorry, everyone on the webinar. Okay. Well, okay. All right, so we just did Grace. All right, next is Noel Olsen. Wow. Okay, hands up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Leave your bias. All right. Bridget Kotti. 1, 2, 3, 4, 5. Great. Emily Markowitz. 1, 2, 3. I know how much time she put into that. So. And Sarah Markowitz. Okay, I already voted. 1, 2, 3. I took that picture myself, by the way. All right. Cool. All right. So now, hopefully, everyone remembered the actual presentations, and we're going to go through one more time, starting with Lauren Gibson, who talked about the solenodons. Oh, yeah. Great. I appreciate the audience feedback. It's my first time hosting. Thank you. Okay, so Lauren Gibson. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Great. James Murphy. 1. Again, really great. All right, Katie O'Reilly. 1, 2, 3, 4, 5, 6, 7. Sami Dow. 1, 2. Grace Ferrara. 1, 2. Okay. Noelle. 1, 2, 4. All right, Bridget. Oh, I recorded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Emily Markowitz. 1. You're wonderful, Emily. Wonderful. Sarah Markowitz. Great. Okay. So just hang tight for a moment while I get the results over here. Chat amongst yourselves. Relish in how wonderful that was. Hilarious. Oh my gosh, Janet. Okay. All right, everyone. Quiet. Order. Okay. Really, really wonderful job. Let me just state that again. This was a bunch of fun, and I really enjoyed hearing about people's research and some of the work they're doing with their fellowships. So the votes are in, and we have 2 winners. One for the slides, which was Lauren Gibson. We have cookies shaped like lobsters and seahorses and starfish or sea stars. And then for the slide, we had oh, I'm sorry. Oh, I just messed that up. Okay, totals. Okay, my bad. All right. So for the slide, it was Noelle. And then Lauren, you still won. Lauren was for your presentation. So we have cookies for everyone and cupcakes and watermelon over here. So thank you everyone for showing up. What a great afternoon, and have a great rest of your week. Thanks, Lauren.